Hey guys, there was a Division 4 contest yesterday on Codeforces and I decided I'll try sort of like speedrunning it. I've just started the virtual participation um, and I'll see how fast I can solve all the problems. I have a timer here. Alright, 3, 2, 1, let's go. Oh, I'll start my stopwatch. And hopefully this problem A will load. Okay. I need to print out which division. Okay. I'll put the problems on my other monitor because basically for most of these problems I'm gonna be writing it as I read the problem. So I'll read in a number and I'll do let's do no, I'll just do ifs. I do if n is bigger than or equal to 1900. I print 1. N is bigger than or equal to 1600. I'll print 2. N is bigger than or equal to 1400. I'll print 3. Else I'll print 4. I'm not even gonna run it, I'll just try submitting. Okay. Problem B. I have an array of n elements. Print any value that appears at least 3 times or print -1 if there is no such value. Okay. I have, let's do how should I do this? I'll do a frequency and then yeah, it's hard to explain it while I'm coding because basically because this is done pretty fast. I'll explain it at the end, I guess. Wrong answer on this one. Okay, I guess I need to be a bit more careful. If it appears at least 3 times. Wait, okay. I don't print new lines and there are multiple test cases, okay. Okay, good. Now, add 1 to every element with an odd index, or add 1 to every element with an even index. Determine if after any number of operations it is possible to make the final array contain only even numbers or only odd numbers. If you can make all elements have the same parity. I can only do that if all odd or all odd positions and even positions have the same parity. So let's make C. And I have for these problems, it's not about the algorithm, it's equals a0 div. This is the it's hard to explain. So in these problems, it's not about how good the solution is, it's about how fast you can code it. And there are at least 2 elements. Let's say originally okay is 1. If I div 2 equals 0 and ai div 2 doesn't equal, if I div 2 equals 1 for the odd positions, if ai div 2 doesn't equal to the parity of the first element, then it's 0, and then I print out yes, no. Yeah, I'll test it. Yes, no, yes, yes, okay. Yeah. I could just go on to the next problem at this point, but I like to see the verdict. Okay. All initially white. Using a stamp, you can stamp any 2 neighboring cells such that one of them becomes red and the other becomes blue. Stamp can be rotated in both ways, okay? Yeah, so I cannot stamp off the edge. Is it possible to make it using the stamp 0 or more times? That means I cannot make it all black, or I cannot make it all red, or all blue or all red, but I think I can do everything else. Oh, and also there are white ones, okay. Red, white, white, red, red, no, that's also not possible. Because some of them might remain white, okay. I have, let's say I have 2 whites of the edge. That makes it more general. And in that case, I can only have, I cannot have only one color between 2 whites. And other than that, I can have everything. So between 2 whites, I cannot have the same, only one, the same color, right? Here, I cannot have that. This one should be possible. 1, 2, 3, 4, 1, 2, 3, 4, yeah. This one's not, this one's possible. This one should be possible. No, because it's between two whites. One black between two whites, one between two whites. This one should be possible, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So I'll do what I'll do. I have int as 10. Let's have one white originally. For int I equals 0, or I'll do and I have for int I have count b equals 0, count red equals 0. Yeah, in a segment. I smaller than, I added two elements, so I plus 2. I actually don't need to add those elements, right? Okay, if plus equals si, if it's blue, I say red, count of red is increased when the string is r. If si equals white, if one of them is 0, no, if C, R, and not B, yeah, I'll do that, or count black and not count red. And at the end I have to do the same check. And now I just print. Let's make it uniform. Yeah, it's hard to explain anything while typing, but yes, no, 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 yes, 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 no, yes, no, yes, no. Okay. I'll try to come up with a proof for that later. And explain why that works. Okay. E, F, E. And strings, each of length 2, consisting of lowercase from A to K, so that E, F, G, H, I, J, K, that's 11. IJ such that a string differ in exactly one position. Huh. Okay. I have some test cases. I have string So I'll first just read in all of the strings, and I need to, so at each position I need to check how many previous positions there are. I'll store the number of positions that start in A and start in I and end in something that's not I, or not, yeah. So I have something like P of 11, 11, and this can be pretty large. First I'll need to empty it to zeros. Let's make it 12, 12. And answer is gonna be increased by dp of si0 minus k I need to have two dp's, dp1 and dp2 of 12, 12. And so first it's dp1 and this is going to be negative, so it's k minus si0, k minus si1 plus dp2 of k minus si0, k minus si1. And the next thing I do is for int j equals 0, j is smaller than 12 plus plus j, dp1 of if a plus j does not equal the second character, if a plus j doesn't equal si1, pi of where the first character is si0 minus k and the second character is not j, I'll increase that by 1. So and if basically what I'm doing here is dp1 is the number of strings such that the first character is I and the second character is not j. That means they differ in exactly one position. dp2 is such that the second character is j and the first character is not I. Here for this string, for all the j's where a plus, where the second character is not j, I have a string where the first character is this si0 minus k and the second character is not j, and for the second one a is not equal to si0. The first character is not j and the second character is Damn. I hope that works. I got a little bit. Okay. Right. K minus. Why is it only up to K? That's weird. Oh wait, it's wrong right now. Okay. Okay, let's think this through. When I have some string AB, I need to find all the previous strings that start in A and do not end in B. And I need to find all the strings that do not start with A and end with B. First char is I, second not J. I'll just do yeah, that's much easier. I don't know. I don't know why I went with this solution. It's much easier to go over for in j equals 0, j smaller than 12 plus j if count of strings that start with j and end with k and with si1 minus a. Yeah, that's the problem. If a and next what I'll do is just deal si0 minus a psi1 minus a. Okay. Okay, I'll explain that. So what I was trying to do would work, but it's much more complicated than just doing this. Yeah. F, G, and candies put from left to right. Of course, if Alice ate a candy, Bob can't eat it. Okay. The goal is to eat the same total weight of candy. What's the most number of candies? What is the most? What is the most number of candies they can eat in total? So I need to get a suffix sum equal to some prefix sum. So if 7, okay. Okay. And won't be too big, but still I'll make it long longs. And I go for if I equals and I'll make these long longs, though I'm pretty sure it cannot overflow. Calls AI if I do pause equals lower bound pref plus if lower bound prefix plus I of yeah, all of the weights are at least one, so there's, yeah. Then ans equals maximum of answer and pref of pause position is smaller and position plus something like that. Okay. Okay, I just need to fix my off by one errors and I'm good. So, what does the lower bound give if there's no such position? I don't know. This is why I need to this is this type of stuff that you will never understand. I think it's just you have to try it out every time. So in the lower bound, if all of the numbers in the array are no, but that's never gonna happen. Okay. And let's print out some information. Okay, why is it 1? Do I just need to do +1 here? Yeah, that seems to work. But I'm not sure about my off by 1 errors. Oh, okay, it got accepted. Yeah, I guess after a point, intuition just does it. There is a grid with n rows and m columns. and three types of cells: empty, stone, obstacle. The floor, an obstacle or other stone which is already immovable. And I need to simulate what this will look like. How big is the grid? It's pretty small. Okay. What's the simplest way to simulate this? Yeah, I don't need to do anything fast because the complexity is it's 50 by 50, so I'll just G. I go column by column. I go through the columns bottom to top, and I just simulate all the. So I go j equals 0, j smaller n plus j, column by column. I equals n minus 1 I 0. If Sij equals star, while S of I plus 1 j, while I plus 1 is bigger than or equal to, no, is smaller than n, and S of I plus 1 j equals empty, kj equals dot sk plus 1 j equals star, and I increase k by 1. I'll print a new line too. For problems with large inputs, I like to weaken the inputs. Okay, it seems to be working for this. Usually these implementation problems are the most difficult for these type of contests, but this one was pretty easy. And now H, which seems to be easier than G, judging by the number of submissions. That AND denote the bitwise AND operation, or denote the bitwise operation. You're given an array A of length n and k and a non-negative integer k, okay, at most k operations, select an index I and replace ai with ai or 2 to the j, so I turn on the jth bit, Okay. I performed. Oh, no, 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 no. Okay. Need to make sure the end is as big as possible, and I have at most k operations. Okay. For each bit, I calculate the number of, and I go from largest to smallest. Okay. Here's so for each bit, I calculate the number of operations needed to turn on the jth bit in the end. So it's first I have int ops of 31 up to the 30th bit. I do first of all, for int j equals 0, 31, ops of I need n operations for each of them first, and then I like to use j for counting bits, so that's when I have a loop just here by itself. I'm not going to use I, I'm going to use j because I usually use j for counting bits. If I can do all, that's good. And then I also need to read in k. I go for in j equals 30. If ops of j is smaller than or equal to k, k minus equals ops j equals 1j. Okay, nice. What seems to be the problem here? Segmentation fault. Oh, I do. It's just simply j. Okay. Oh, I'm done. Let's look at the timer, though. I just realized that there's actually like a built-in timer, but 39 minutes. Pretty good. Pretty good. Let's look how I did in the standings. I enjoyed that. Oh, no, probably my friends didn't really take part. Where am I? Yeah. What was problem? Yeah, that took me the most. most amount of time. A, B, C, D, E. What was problem E? Yeah, it's the two-letter string. I tried doing something different and that wasn't too smart. Okay, I'll do like 1 minute explanations for all the problems and I'll draw or something. Yeah. Problem A, we basically had to print out so we were given a number. If the number is bigger than 1900, we have to print this. If it's between 1600 and 1899, we have to print this, etc. Basically, you just write up 4 ifs. Yeah. You could also do something cooler. I'll do like an alternative solution because I think I have a cool solution idea. Let's say you wanted to do it faster. You could do something like I have a map into string zero I. So I like pre-calculate all the solutions, but I just realized that I'll still do it. Let's put this on my other monitor. So what I'll do is 1399 minus 5000 map I equals division equals 4 from 1400 to 1599. I'll do 3, 2, 1. From 1600 to 1899 I'll do 2, and up to 5000 because that's the max and the input. From 1900 I'll do 1, and now the solution print division. Yeah, I don't know, that I think that looks cooler. I'll submit it. Wait. What? Okay, let's try it for the. Wait. Let's try it for the examples. Yeah, I don't know. I just thought it would be a cool idea to pre-calculate all the answers. Oh, I just print out division for all of them. Oh, I map it to a string for some reason. Okay, yeah. Yeah, it should work now. Okay, let's go through the problems actually. I won't spend this much on the other problems. Problem B. Given an array A of n elements, print any item that appears in it 3 or more times. What I did is I make a frequency array with a map. Originally I set the answer to -1, and if the frequency of any number reaches bigger than or equal to 3, then I'll set the answer to x. Then I'll just print answer. If none of them reached it, I'll print -1. If any of them reached it, I'll print the last one that reached it, but I can print any that reached it, so that works. In problem C, basically the problem statement, what it actually says is we can switch the parity of all elements, or we can switch the parity of all the odd indices or all the even indices. But if two numbers with even indices have different parities, we'll never be able to make those have the same parity, because if there's a 1 in position 0, there's a 1, and let's just draw this, but I think it's pretty obvious. So position 0, 1, 2, if there's a 1 in position 0 and a 2 in position 2, when we switch their parity, this will become 2, this will become 3, and they'll switch opposite to each other, so they'll never have the same parity, which means we just need to check if all the even elements and all the odd elements, I mean all the odd positions and all the even positions, have the same parity. What I do is I check the parity of the first even position, the parity of the first odd position, and I check if all the subsequent numbers have the same parity in odd or even positions. If they do, then it's yes, otherwise it's no. Problem D, I don't actually have proof for that yet, but I think I can construct it. Basically, what I did is I realized that in general, the only thing that I cannot have is have a white square, have a couple of blue or red squares, but squares of the same color, and then another white square. I cannot have this. This is impossible. That's easy to see that this is impossible. The 0th and the n plus 1th position can be assumed to be white, because I won't change that, so if they're all blue, then that eliminates this sort of edge case. I guess we can have anything else. We can sort of construct that. So until the last element, so let's say this is blue, I stamp it with blue, this will be red, but if this is also blue, I'll overstamp it. And I get all the way to the end. If the last two are blue, then I can reverse the stamp, go back. Yeah, I'm not sure yet how to solve this. In general, a sequence can look something like this. So there's a bunch of blues, then a bunch of reds, then a bunch of blues, then a bunch of reds, then white. I'll choose the first red, and this can be inverted, so that we can do this without loss of generality. I choose the first red and I do blue-red stamps up until here, so this part will be okay. That wanted to be fine. And what I'll do here is I do red-blue stamps up until this position. Then I do blue-red stamps up until here. And then I'll do I'll do one final, I go from here with red blue stamps and finish it from here to this switch. I guess I just need to find one position in the array that is red blue, solve everything that's next to it. I can do that by only looking at the right side of the stamp or the left side of the stamp, because they'll be stamped over. And at the very end, it doesn't really matter what these two middle positions were, because with the last stamp I'll stamp this to red blue or blue red. So if there's at least one inversion, we can solve it. Or there's like one position where there's a red and a blue, or a blue and a red next to each other. Yeah. I didn't think this through during the solving part. I just implemented the first idea that came to my head. And yeah, I count the number of blues and the number of reds between each pair of whites. And if there's only red or only blue, then I cannot solve it. Otherwise I can solve it. And I have to watch out that I've assumed, or I sort of put a white at the end. So I also need to check the last position. Okay. For E, I had some stupid idea which I struggled with like 5 minutes, which wasn't very good. For E, basically, all I do is I have some dp I j is the number of strings that look like I, j, so that's the ith and the jth character. I can also do this with maps, but it's easier, so the ith character, we can get that by a plus I, and also we can convert a string to their position with taking some character c and subtracting c minus a. I'll get the position of this element. And so when I'm at some string that looks like c1, c2, I have to add the number of strings that start with c1 and do not end in c2. So the second is not character 2, and calculate the number of strings that start with not character 1 and end in character 2. And I do this by looping over the dp values and adding all c1, c2, where c2 is not c2, or adding all the, yeah. And this can be done with in like 10 or up to the size of the alphabet, so the complexity of this algorithm will be n times size of the alphabet. Yeah. And here the size of my alphabet is pretty small. It's up to k, so that's 12 or 11, which means that I can do it fast. I don't know why it's a to k, so this could have easily been a to z. That threw me off a bit. Yeah. Here I just iterate over all the characters, and I add all the characters where the first letter is not c1 and the second character is c2, and I do the other way around, so I iterate over all the elements where the first element is c1 and the second is not c2. And after that I add this number to my dictionary. I could technically add it earlier because this wouldn't change the answer anyway, but that doesn't matter. F, eating candies. Basically I look through all of the, so the problem was Alice eats some prefix of the array, Bob eats some suffix of the array, and we have to find the largest sum of the length of the prefix and the suffix such that the sum that they eat will be the same. What we can do is we just iterate over all of the suffixes that Bob can eat, right? He eats from the right. We iterate over all of the suffixes that Bob can eat and check if there's a prefix that ends earlier than I, which is the last position that Bob ate, and has the same sum as the suffix that Bob ate. So we just store a prefix array, and we do this with a binary search with a lower bound. Obviously the prefix array will be sorted because for all elements the next element is bigger than the last. That's because all of the weights are positive numbers. And we just check all of the suffixes. For a certain suffix, the prefix that Alice has to eat is determined by the suffix that Bob ate. So this works. And I had this one off by one error. The position is, because it's 0 indexed, we need to add 1. Yeah. Okay, problem G. Problem G was implementation. I found a pretty easy way to implement this. What I do is I go through the table. I think I should explain the problem first. We have a grid with rocks, obstacles, empty space, and the floor. And we need to simulate what this grid will look like after all of the rocks have fallen down. A rock will fall until it hits an obstacle, or it hits the floor, or it hits a rock that has already fallen to the bottom, or that has already fulfilled one of the previous criteria. So this rock right here will fall onto this rock because this rock cannot fall lower. The way I did this was I went through the grid column by column, because two columns won't interact with each other, and then I go through a column from bottom to the top, and each rock I find, I will push it down until I can push it down. I know that if it hits a rock that's below it, I've already transformed that rock into its final position, so it will stop at that point. I do this with this while loop, and this will be n cubed complexity, but n is at most 50, so that doesn't really matter. Okay, finally, maximal end. Problem H was a bit more interesting, and I think it's actually a pretty good problem. We were given an array A of length n of non-negative integers, and what we can do in one operation, and we can perform at most k operations, is select an index I and XOR AI with some j, not XOR but OR. So we can set the jth bit of some number, and we have to maximize the end of all the numbers. Basically what I did is, so for the end of the final array, for the jth bit to be turned on in the final array, we have to have the jth bit turned on in all of the elements of the array. That's basically what AND does. So the jth bit has to be 1 for all of the elements of the array. Let's do j plus 1 bit, that looks like 0. So first of all, I calculate the number of operations I need for the jth bit to be turned on for all numbers, for all j bits. Originally it's n because we assume that all of them are 0. I read in the numbers, and if the jth bit of some number is not 0 but 1, then I will need to do one less operation to have all of them turned on at the end. So I make this operations, I subtract 1 from it, and at the end I go through the bits from largest to smallest, because the largest bit will is the most so the largest bit adds more to the numbers, more to the answer than all of the bits smaller than it combined. So I go through the bits from largest to smallest, and if I can turn on the current largest bit, then I turn it on, and this way we'll get an optimal answer. Yeah. All right. I want to see how fast people. So the problem that gave me the. So problem E was the worst for me. I spent too much time on problem E. But overall, I enjoyed the problems, especially problem H was pretty cool. And out of the first few problems, I think there was also a cool problem that I liked. The odd even increments, that was sort of cool. I don't know. E was not bad. Alright, so thanks for watching this video. I hope it helped some of you, and have a great day.